Build a local demo AI agent with mock tools, then understand what each code block is responsible for. Let's begin with what we are building. We are building a local demo AI agent workflow inside Cursor. Cursor acts as the AI code editor host. A local MCP server exposes mock tools to that host. The first mock tool looks up fictional customer data. The second mock tool simulates a follow-up task. No real customer data or production system is used. The goal is to understand what each code block is responsible for. That sets up how the pieces connect. The AI code editor host is where the agent runs. Inside it, an MCP client connects to our local demo MCP server. The server lists mock tools with names, descriptions, and schemas. The agent chooses a tool when the task needs external help. The tool returns a demo result. The agent uses that result to continue the workflow. This is the basic pattern behind tool using AI agents. With how the pieces connect in mind, the next piece is why this is demo only. Tool using agents can become powerful very quickly. That is why this tutorial uses only mock data and simulated actions. The customer records are fictional. The follow-up task is stored only in memory. Nothing is sent to a live CRM, ticketing system, email inbox, or database. Production use needs authentication, permissions, audit logs, rate limits, and human approval. A safe local demo is the right first step. That idea leads directly to what you will learn. You will set up a small TypeScript MCP project. You will create fictional local demo data. You will build a read-only mock lookup tool. You will build a simulated follow-up task tool. You will connect the server to Cursor with mcp.json. You will test the agent with a prompt that requires tool use. You will learn common mistakes and production safety thinking. Once what you will learn is clear, project assumptions becomes much easier to understand. We will use Node.js and TypeScript. The server runs locally with stdio transport. The MCP tools are mock tools only. Zod validates tool inputs. The project uses a local .cursor/mcp.json file. The code samples are small enough to understand on screen. You can later replace the mock layer with safer production architecture. From there, the next practical step is project setup commands. The setup creates one local demo project folder. The MCP SDK provides server and transport utilities. Zod helps validate tool inputs. TypeScript gives stronger checks while building. The SRC folder holds our server code. The .cursor folder holds the project-level MCP config. This keeps the demo isolated to one workspace. This sets up the next important point, folder structure. The folder structure is intentionally simple. src/mockdata.ts stores fictional sample data. src/server.ts defines the MCP server and mock tools. .cursor/mcp.json tells Cursor how to start the server. Package.json stores scripts. Config.json controls TypeScript output. Small structure makes the first agent easier to debug. That sets up package scripts. The package scripts define how we run the demo. Dev runs TypeScript directly while experimenting. Build compiles the code into dist. Start runs the compiled JavaScript server. For Cursor, the compiled server is cleaner for stdio launch. This matters because stdio servers should avoid extra output noise. The scripts connect development and runtime behavior. With package scripts in mind, the next piece is TypeScript Output. The TypeScript config decides where compiled files go. Root dir points to src. Out dir writes JavaScript to dist. Node next supports modern module imports. Strict mode catches mistakes earlier. Cursor will launch dist/server.js through mcp.json. So this config is part of the runtime path. That idea leads directly to fictional demo data. Before tools can return results, they need demo data. This file uses fictional companies only. Demo Retail Company and Sample Manufacturing Limited are sample records. The Open Items field gives the agent something to reason about. Mock tasks is only an in-memory list. It resets when the server restarts. That keeps the action tool safe and clearly simulated. Once fictional demo data is clear, create the MCP server becomes much easier to understand. The server file starts by importing the MCP SDK pieces. MCP server represents the local tool provider. stdio server transport lets the host launch it locally. Zod validates tool arguments before execution. The server name identifies this demo tool provider. At this point, the server exists but has no tools. The next step is to expose safe mock capabilities. From there, the next practical step is Tool 1, Mock Customer Lookup. The first tool is read-only. It receives a customer ID from the agent. It searches the fictional mock customers array. If found, it returns a JSON demo record. If missing, it returns a clear not found message. Read-only tools are the safest way to start. They help you test tool calling without side effects. This sets up the next important point, why the input schema matters. The schema is the contract between the agent and the tool. It tells the agent which arguments are required. Here, customer ID must be a string. The description gives the agent an example value. Clear schemas reduce failed tool calls. They also make tools easier to inspect and debug. Good MCP tools need good contracts. Good MCP tools need good contracts. That sets up Tool 2, Simulated Follow-up Task. The second tool demonstrates an action pattern. It receives customer ID, owner, and reason. It creates a simulated task string in memory. It does not create a real ticket or task in any live system. The response clearly says simulated task created. This teaches action tools without production risk. Real write actions need approval, permissions, logs, and validation. With Tool 2, Simulated Follow-up Task in mind, the next piece is read tools versus action tools. Read tools fetch information. Action tools change something or simulate a change. That difference matters for safety. A mock lookup is low risk. Even a simulated task tool should be clearly labeled. Real create, update, send, or delete tools need stronger controls. Use human review around anything that affects real people or systems. That idea leads directly to connect the server with stdio. The tools are registered, but the host still needs a transport. For this demo, stdio is the simplest local transport. The host launches the MCP server as a subprocess. The server reads MCP messages from stin. It sends MCP messages back through stout. That is why protocol output must stay clean. Logging should go to str, not stout. Once connect the server with stdio is clear, build the local server becomes much easier to understand. The cursor config will point to the compiled server file. That means you need to build before testing. npm run build creates dist/server.js. If you change the tool code, rebuild again. Otherwise cursor may run an older compiled version. This is one of the most common local MCP mistakes. The build step connects your TypeScript edits to cursor runtime. From there, the next practical step is connect cursor with mcp.json. The .cursor/mcp.json file is the project level connection point. It tells cursor which local server to launch. The type is stdio. The command is node. The args point to dist/server.js inside the workspace. This keeps the server scoped to the current project. Project level config is safer for a tutorial than global configuration. This sets up the next important point, keep secrets out of code. This demo does not need real credentials. Still, it is important to learn the safe pattern early. Do not hardcode API keys in MCP server files. Do not commit real secrets to mcp.json. Use environment variables for future integrations. Use least privilege credentials for production. For this tutorial, stay in demo mode. That sets up enable the server in cursor. After building, open the project in cursor. Enable the local demo agent tools MCP server. Cursor should discover the mock tools. You should see mock lookup customer and mock create follow-up _task. If they appear, the local MCP connection is working. If they do not appear, check build output and config paths. The agent can only use tools that the host discovers. With enable the server in cursor in mind, the next piece is test with a local demo prompt. The test prompt should force tool use. It asks the agent to look up mock customer 001. Then it asks for a simulated follow-up only if the demo data supports it. This tests lookup, reasoning, mock action, and final explanation. The prompt is explicit about using the local demo server. The output should explain that the task is simulated. That keeps the demo behavior clear and safe. That idea leads directly to expected agent flow. The agent first plans what information it needs. Then it calls mock lookup customer. It observes the fictional customer record. Because open items are present, it calls mock create follow-up _task. It receives a simulated task confirmation. Finally, it explains the result in plain English. That plan, tool, observation, action, response loop is the core pattern. Once expected agent flow is clear, verify with CLI checks becomes much easier to understand. CLI checks are useful when the editor view is unclear. List configured MCP servers first. Then list tools exposed by the local demo server. If the server appears but tools are missing, inspect tool registration. If the server is missing, inspect mcp.json and file paths. If the server fails at startup, check logs and build output. Debugging is easier when you separate config, build, and tool issues. From there, the next practical step is common error, no tools found. No tools found usually means the server did not start or did not register tools. Check that npm run build created dist/server.js. Check that mcp.json points to the right file. Check that Node is available from Cursor's environment. Check MCP logs for startup errors. Avoid writing normal logs to Stout and stdio servers. Stout is reserved for MCP protocol messages. This sets up the next important point, common error, bad tool arguments. Sometimes the server connects but a tool call fails. This often means the arguments do not match the schema. The agent may send the wrong field name. It may miss a required field. Improve tool names, descriptions, and schema descriptions. Add clear examples like mock customer 001. Better metadata helps the model choose and call tools correctly. Better metadata helps the model choose and call tools correctly. That sets up add guardrails before real systems. The local demo teaches the pattern safely. A real system needs a different level of design. Use authentication and scoped permissions. Add audit logs and monitoring. Add validation and safe error handling. Require human approval for right actions. Do not connect agents directly to production workflows without safeguards. With add guardrails before real systems in mind, the next piece is extend with a local mock API. After the array-based demo works, you can extend safely. A local mock API is a good next step. It still avoids production systems. The Lookup tool can call localhost instead of reading from an array. This teaches HTTP error handling and async calls. Keep the tool interface simple while the backend changes. Only move toward real APIs after security design is ready. That idea leads directly to where this pattern applies. This local demo pattern can map to many workflows later. A support assistant could search mock ticket data. A finance assistant could inspect sample invoice exceptions. An HR assistant could answer from demo policy files. A developer assistant could inspect a test repository. The architecture is reusable, but production controls must come first. The right question is not only can the agent act, but should it act? Once where this pattern applies is clear, what the local code enables becomes much easier to understand. You now have a local demo MCP server. Cursor can discover its mock tools. The agent can call a read-only lookup tool. It can call a simulated action tool. It can explain the result after observing tool output. The code demonstrates agent behavior without live external effects. That is the safest way to learn the pattern. From there, the next practical step is common beginner mistakes. Do not expose too many tools at once. Do not use vague tool names. Do not skip input schemas. Do not hardcode credentials. Do not start with real write actions. Do not ignore logs when tools fail. Do not treat MCP as automatically safe. Small, clear, mock tools are best for learning. This sets up the next important point, next improvements. The next improvement is persistence with a local file or test database. The second improvement is stronger error handling. The third improvement is better observability. Log tool calls, arguments, timing, and failures safely. The fourth improvement is human approval for simulated write actions. The fifth improvement is a local mock API layer. These upgrades build skill without jumping into production risk. That sets up final content recap. Cursor can act as the AI code editor host. MCP connects that host to a local demo server. The server exposes mock tools with clear schemas. The agent can call tools, observe results, and respond. mcp.json tells Cursor how to launch the server. Build, logs, schemas, and paths are key debugging areas. The tutorial stays local, mock, and educational by design. You now understand the full flow from code to agent behavior. To wrap up, here is the key takeaway. You now have a structured overview of building a local demo AI agent with Cursor and MCP step by step. Review the core ideas, connect them to examples, and revisit concepts like what we are building, how the pieces connect, why this is demo only when practicing. Subscribe to Easy Machine Learning Guide if you want to learn AI through simple explanations and real industry examples.